Hello guys, good morning. Today we have here with us Dr. Chandrakant Ojha from the Department of Earth and Environmental Sciences, IISER Mohali. Sir, for those who don't know about your what you work on, so can you give us a brief introduction about your work and yourself?
Yeah, first of all, thank you so much. Myself, Dr. Chandrakant Ojha, an assistant professor in the Department of Earth and Environmental Science. I work on advanced radar remote sensing for the application of any kind of natural disasters that happen on our Earth surface. Let's say from volcanoes to earthquake studies to even any other kind of natural phenomena like floods, cyclones, the kind of disasters, groundwater issues, and other stuff. Okay, so that is kind of work we are currently focused on.
So like you have mentioned like sensing and remote sensing and all that stuff. So sir, like we have like groundwater table and the aquifers we have underground.
Mhm.
So those are depleting because we are using up like too much stuff like
Yeah.
the gas reservoirs and all. How do those things like affect the geomorphology? Because in India we don't have any specific like continental boundary
Mhm.
among the continent. It's all like far from the Afghanistan to China, so in along the Himalayas. So how like local subsidence zones has affected the local community and farmers and all that?
It's a very interesting questions, and it's a very promising issues, which is a very uh, it's not something very quickly you can notice this. It is a very slow process. Okay, so groundwater is fresh water and is very limited. Okay, so people are using it for several purposes, whether it is agriculture or whether it is industries, whether day to day's life. Okay, but we have no idea how much groundwater we are extracting. We use for agricultures without any control on it. So once we start extracting groundwater over a long period of times, then what happens? The ground that which is below the surface, so the water will actually started depleting. Okay, and what happens? The pressure will create on the surface level. Okay, so if keep on doing the same things, this limited resources will get start replenishing. Okay, so it will deplete it continuously and will lose the amount of water over a period of times. What happens? If we are not doing any recharge process or through natural or artificial recharge, the surface on the above the ground, what happens will start shrinking. That is we call land subsidence. Okay, and the infrastructure that is present on the surface will have the possibilities of cracks. So you can see that many places. So basically in Chandigarh or basically in the northern part of India, um, groundwater depletion is a significant issue. This is not the case only in India, but also many places across the world. So one of the important example is Central Valley of California, where the because of the groundwater extractions, the land is subsiding in centimeter scales. So we have seen there are research which is talking about 20 plus centimeter scale of deformation, and that is just due to the groundwater extractions. So imagine if this is continuing over a long period of time, what will happen to the infrastructure which is present above the surface? Your land is not stable, and you are building any infrastructure, it will simply create damage to your infrastructures, which is a slow process of geohazard phenomenon. Okay? So we have to be very careful, and we need to think about how we can actually handle it or manage it effectively. Okay? So that is basically an important aspect we need to think. And in Indian context, the geology, if you will look from the geological point of view, so there are different layers of sediments at present. So might be alluvial one. Some places will be a rock type surfaces. Okay, so depending actually the different areas. For example, in agriculture land in in our Punjab areas, they are mostly alluvial ones. So it's very fertile lands and also very soft lands. So anything changes in the groundwater, it can easily reflect or can respond to our infrastructure, basically on the surface level.
So like the same thing goes for the like oil and gas reserves and aquifers we have
Exactly.
underground.
So when we say about the extraction, so it's not just only groundwater extraction. It can be happen with any mining things that we can do. So basically underground resources. So any exploitations of underground resources can lead to infrastructure damage because of the land sinking, or let's say subsiding of the land. So which continuously declining, and over a period of times it can cross a certain threshold. And when it cross a certain thresholds, it is very prominent. We can notice many of these cracks and signals on the first thing we can notice on the buildings. Okay, so that we can see. Even the dams and any other kind of other infrastructures that can easily affect, and we can notice that very frequently.
So, sir, like, what is the like recent most exciting breakthrough of your research, like, of which?
Yeah, so we were working on this understanding how much the groundwater has been lost. So in terms of volume, so volume of groundwater has been lost that we have not noticed it. So it's maybe because of the agriculture, or maybe some other, the industrial
Industrial
activities
uses.
or daily uses. But we do not have quantified how much actually the groundwater has been lost in particular, let's say Chandigarh and Mohali areas. We know that the land here is also not very much, stable, um, and it is subsiding at a range of, 10 plus centimeter years in some places, in a hotspot zone. So we worked on some of these um, research how we can use the satellite-based observation data, integrating with the groundwater related observational data, and come up what are the dynamics of the groundwater, how much the groundwater volume has been lost, what is the capacity of the groundwater volume has been, so capacity of groundwater has been, lost. So whether we go to any inelastic conditions where our land or water cannot be, replenished, or land cannot recoverable one. So those kind of research we are doing it, and recently our research works that is kind of under process. So we noticed that about 3% of the total capacity of groundwaters in Chandigarh and Mohali, so from 2016 to 2023, so in a 6 year of time, 6 to 7 year times, 3% of the total volume of water has been lost, which is equivalent to, let's say, 1 million size of a Olympic size swimming pool. So in a layman language, you can understand. So that much amount of water has been lost, which is not going to replenish. So we are not going to get it back. So imagine water is limited and we are losing such a huge amount of water for whatever be the purpose, but we are not going to get it back. Yeah.
So, like, apart from like groundwater replenishment or like using the oil reserves for as a carbon storage, what other methods, like scientifically or on a local community level, can we like have, or the precautions we can have to avoid these things?
To avoid these things, it is needed very much to look from the holistic approach in a multi dimension. So it's not just only the user, but also the policymaker has to, think about it. As a scientist, it is our job to, to show the issues, concerns, and what are the possible way that we can actually manage it. We cannot control it, means we cannot stop it, but we can try to reduce the effect, and maybe it should not continue over long period of time with the same thing. So one of the first is we have to basically stop doing over exploitations of groundwater. We need to look for an alternate source of water for our daily purpose. Let's say for drinking purpose, or even for agriculture one. So our policymaker has to think about it. What is the best way that we can provide our farmers, because that is needed, right? So they cannot stop using water, otherwise it will be another crisis. So that is needed, but we have to look for how we can use the surface water, how we can preserve actually the natural water, let's say rainfall water. So sometimes it happens that the many of the water that we receive during the um, let's say monsoon seasons, we couldn't really preserve them. So if we could do that, so that is some way we can recharge our aquifer systems. Okay, and whatever we extract, we can actually give them back. So that is a way we have to look for better solutions. This is just one way, but there will be many other approaches. There in the international world, so people are also looking for different methods. So if, starting from just from the home itself, we can also think about how we can minimize our water, okay, so that we should not lost a lot of water. We can use optimize use of our water. So water conservation and preservation is very much important.
And like the next question I would like to ask, like, what skills or background does a student needs, like, if they want to join your lab or a company work under you?
Yeah, it is an interesting question. The issue is it's very common, and this type of research, what we are doing, basically using satellite-based data, analyzing, processing, and to investigating it. So we really do not need any particular type of background. We look this topic as an interdisciplinary. So basically, multidisciplinary approach. Whether a science student or a BTech student can also be a part of this. So science, when we say whether it is a physics or maths or bios, everyone can be a part of this. The only is interest. Okay. At the same time, when a computer guy who can actually have experience of computation one, they can handle this sophisticated data, huge and large of satellite data, how effectively they can process and analyze. So one skill is needed how we can do a technical development, understanding the new algorithms or basically developing new algorithms or framework to integrate the satellite data or multi-satellite data which has a different resolutions and over long period of times. At the same time, we need people who can analyze those data. So the students from any of these backgrounds or have interest, uh, they can definitely do this participation. Yeah.
Good to hear, sir. Like, so, sir, like the next question is, like, what was the instance, like, or the thing, like, which made you into, like, you thought that you will be like contributing to this field, you'll be studying like remote sensing and GIS.
Yeah, it's a very interesting question. So basically, my background is from physics. I did my physics from Delhi University. So initially, after finish my masters, I was thinking I may use this physics in the use of society. So I was very keen then to move towards the applied physics. So I pursued my MTech from IIT Bombay, where I get to know about this remote sensing, where we can use this satellite-based observations for for several applications, and the interest begins there. So I started feeling actually the interest where we can see that we can immediately show through our results how the society or how the common people can understand from this. And this interest actually create me, which actually lead me to pursue some PhD program outside India, where I get to know about this method InSAR technique, which is advanced remote sensing, where we are using radar, microwave part of the remote sensing satellite data. There actually I get to know about how to do some advancement or new algorithm development, processing such a huge large number of sophisticated satellite data. But then I was keen interest to basically explore the application part of this technique. Then during my postdocs and when I was in a scientist in Australian government, so I use this technique integrating with other different sensors and data to come up with a several applications. One of the application was how we can monitor the groundwater situations. There could be any other applications like we can look for sea level rise, how actually our sea level rise is going to impact our coastal areas, how we can monitor basically flood mapping through InSAR data, how we can monitor basically earthquake studies. Okay, so these are the different applications. So whether it is from glacier studies to whether it is land use land cover change, whether it's a groundwater, so there are several applications. So that actually create me an interest to pursue this. Yeah.
So just societal impact you.
Yeah, it is actually create me a societal impact because I'm coming from such a background where we have seen that many cyclones, affected our common people, and their lifestyles is changes. People are not finding a quality of water. Farmers are affected by lack of water, so a lot of farmers can die also. A lot of news we heard about that. So we want to create something, a framework, kind of a scientific way where a common people get the benefit uh, through this scientific research. So that actually created me an interest in this.
So the next question I would like to ask you is like where do you like see the field of INSAR, which is said for the advanced sensing of the ground
InSAR.
subsidence and the tectonic movement and all.
Uh-huh.
So specifically, where do you see it in the next coming 10, like
Okay.
2 to 3 decades?
Yeah. So this is also a very important question. So recently, our space agencies, Indian Space Research Organization (ISRO) has recently sent a satellite collaborating with NASA, and that is called NISAR, NASA ISRO Synthetic Aperture Radar Mission. So that is dedicatedly for InSAR techniques or SAR data. Once the data will start available, there will be huge potential to use the data. So far, India doesn't have actually any dedicated SAR satellites before. Of course, there are something like a research one. Uh, but this is actually a long wavelength signal status which has manifold applications. So India has, bright future with this NISA data, and we are looking forward so many of opportunities and outcomes and fantastic results from this data. When we look forward like 10 years of data, we do not have that human skill and actually the resources which we need to explore it further. Okay, so once we'll get these data in a public open space and public domain, there could be a chance of using those data in several applications, and there is a huge future, not just only for the application side, but the same times job perspective as well. So students will also get a lot of job opportunities. There are also some startups also coming to explore this data and to to plan for how they can benefit for the societies and also the corporate or the business as a consultant. So I can see actually huge potentials, which the other part of the world has already been explored at an extent. India is still growing on this. So in this rate, the way actually we are moving forward. So another few years of time, we can see we can actually realize the importance of this technique and methods.
So to wrap up things, my last question from you would be like for the World Environment Day, what is this one message that you would like to share to students or fellow scientists and the people who aspire to become and contribute to academia?
Yeah. Uh, so it's very important is water.
Yes.
If we do not have water, everything will be stuck up. So we have to conserve and preserve our water. And water is precious and very limited. It will have, if we will continuously replenish it or we will not take care of, then we are going to have a huge
Crisis.
geophysical disasters, hydrogeological disasters. Okay. So my only message is there are many important concerns and issues. Water is one of the most important one. So we have to conserve our water. We have to conserve our ground resources. We have to conserve our groundwater, which is very limited. Okay, and we have to use it very optimized way. So whether it is in a scientific world, we have to keep monitoring them. Whether it is user point of view, we have to optimize it, and as a policymaker side, we have to effectively manage and effectively monitor them and come up with a management plan which could be very useful for conservation of waters and preserving water. That is my message. Yeah.
Thank you so much, sir, for your time.
Thank you. Thank you so much.